If your renders are taking forever, chances are it's not just one thing. It's a combination of habits and settings that quietly stack up and cost you hours every single project. And the worst part? You often don't notice the problem until you hit render. And then you wait, and wait, and wait. In this video, I'm going to break down the 10 common mistakes that slow down renders in 3ds Max. Here's the mistake that ties everything in this video together. When renders are slow, the first thing almost every artist does is open the render settings and start tweaking. Lower the noise threshold, adjust GI passes, change the sampling. They spend 45 minutes inside the settings panel and come out with a render that's maybe 10% faster. Don't get me wrong, settings are important, but the reality is that nowadays modern Corona and V-Ray defaults are already very good for most of the scenes and for slow renders. And many times, the settings are not the problem anymore. The problem is almost always somewhere in the scene itself. Sampling adjustments can help, but they won't fix a scene. You can have perfect render settings and still be waiting hours, because the bottleneck has nothing to do with how the renderer is configured. Before you open the render settings panel, take 5 minutes to actually look at your scene. 9 times out of 10, the answer is right there in front of you, and the remaining points in this video will show you exactly where to look. Most of you are using interactive rendering for tests, and that's the right call. But that doesn't mean resolution stops mattering. At 4K, every pass processes 4 times more pixels than at full HD, which means 4 times slower feedback on every lighting or material test. So you need to adjust to your needs and the power of your machine. Simply resize that window to get faster feedback without changing a single setting. Also, instead of rendering the entire frame, you can drag a region over exactly the area you're testing. A specific light, a material, a section of the composition. The progressive renderer throws all its resources exactly where you need them. Another thing, resolution override in the frame buffer. You render at a lower resolution without touching your output settings. One click, much faster feedback, and zero risk of forgetting to restore settings before the final render. Now, sometimes you genuinely need to see a specific detail at full resolution. A texture up close, a material transition, a fine architectural element. In that case, instead of rendering the entire frame, use region rendering in the 3ds Max render settings. You define the exact output area, and the renderer calculates only that portion at full resolution. You get exactly what you need in a fraction of the time. Here's something most artists never think about. You download a material or model pack, load it into your scene, and every texture in it is 8K. Looks professional, must be better, right? The problem is that an 8K texture on a piece of furniture that occupies 200 pixels on screen is loading millions of pixels of data that will never ever be seen. It bloats your RAM, slows your scene parse time, and doesn't contribute visible quality to the final render. The renderer has to load every texture into memory before a single sample gets calculated. In a complex scene with 50 materials all running 8K textures, you're loading gigabytes of data that camera will never resolve. The fix is matching texture resolution to actual screen coverage. Objects in the background, surfaces that are partially occluded, anything that isn't a hero material in the foreground. 2K is more than enough. If you notice that you have a problem, make it a habit to run that check before your final render and downscale anything that isn't pulling its weight. The next mistake is something I noticed in many scenes from a junior artist. Too many lights with no control over what they actually contribute. Here is the problem. Every light in your scene calculates its contribution across every surface, in every sample, unless you tell it not to. An exterior render that has hundreds of interior lights is calculating all of those lights even though they contribute almost nothing to the exterior shot. The light lister is your best friend here. Open it, look at your lights, and ask yourself, if I turn this off, will anyone notice? For anything that doesn't pass that test, turn it off from this specific shot. Turn off lights that don't affect the shot, and avoid calculating lights that are not visible or not contributing meaningfully. Before we continue, let me address the mistake that sits underneath every single tip in this video. Sometimes your scene is already optimized, but your CPU is simply not strong enough for the work you're asking it to do. You've optimized your scene, checked the settings, reduced the texture size, and you're still watching that render bar crawl. At this point, it's not your settings anymore, it's hardware ceiling. This video is brought to you by AMD. The AMD Ryzen Threadripper Pro is the processor that serious render workstations are built around. I mean up to 96 cores, 192 threads, and 384 megabytes of L3 cache. For CPU rendering in Corona and V-Ray, core count is everything. Every core is working on your render simultaneously, which means that Threadripper Pro isn't a small upgrade over a regular desktop processor. It's a completely different category of machine. Here's what that looks like in practice. The Threadripper Pro renders up to 145% faster than the Intel equivalent in V-Ray and up to 118% faster in Corona. Think about what that means for your workflow. For example, a render that takes your current machine 10 hours gets done in under 4. That's not just faster renders. That's more iterations, better final images, and deadlines you actually hit. It's built specifically for AEC workflows, meaning it handles running 3ds Max, your renderer, scatters, and your asset library all at once without the machine slowing down. Check out AMD Ryzen Threadripper Pro processors through the link in the description and find a workstation built around one. Now back to the mistakes. This mistake is a silent killer, and you may not even notice it during rendering, but you'll notice it during that long pause before rendering starts. Unoptimized scatters. You add a few grass patches, some leaves, stones, maybe small debris, and suddenly, your scene has millions of objects. The problem is not scattering itself. Scattering is great. The problem is scattering everything at full quality, everywhere, even in areas the camera barely sees. A common mistake, especially if you don't have a good machine, is using high-poly assets for every single instance. For example, thousands of detailed plants in the background, even though they appear as tiny shapes in the final image. Another mistake is scattering too densely. With no distance fall-off, no camera clipping, and no variation in detail. Instead, optimize your scatters. Use lower poly models for background areas and limit the scatter only to the visible camera area. Reduce density where it doesn't matter and turn on the camera clipping. The goal is simple. Keep the detail where the viewer can actually see it, and don't let your computer calculate things that will never be noticed. Closely related to scatters, but this one is about individual heavy objects. The mistake is keeping high-poly geometry directly inside your 3ds Max scene while it should be a proxy. Architects send you Revit exports with millions of unnecessary polygons. You download a tree from an asset library and import it directly without checking the poly count. Or you get a car model and it has millions of polygons. Now that object is sitting fully inside your scene. It makes the file heavier, the viewport slower, and every time you render, the engine has to parse and prepare all the geometry again. That's where V-Ray proxy and Corona proxy help. Instead of keeping the full editable mesh inside the scene, the heavy geometry is stored in an external file and loaded by the renderer when needed. Your scene stays lighter, the viewport becomes faster, and render preparation can improve a lot. The workflow is simple. Select the heavy object, export it as a proxy, and replace the original mesh. But proxies are not a magic button. If you convert one random sofa to a proxy, your final render time will probably not change much. Proxies help most when the object is very heavy, slows down your viewport, bloats your file, or is repeated many times. One high-poly tree used many times across the scene? Definitely proxy it. A detailed car model used 6 times in a parking lot? Convert it immediately. A single unique object? Maybe not worth the effort. So the rule is simple. If the object is heavy, finished, and especially repeated, turn it into proxy. Another mistake is adding too many render elements just in case. Render elements are useful. They give you more control in post-production. Masks, lighting passes, reflections, refractions, denoising, cryptomate, and so on. But they're not free. Some elements are cheap, but others can increase memory usage, add extra calculations, or slow down the rendering or saving process. And even when they don't multiply the render time directly, they can make your render heavier, bias bigger, and the workflow slower. The common mistake is turning on every possible pass, because maybe you will need it later. You probably don't. If you are rendering a simple still image, do you really need 20 different elements? Do you need every lighting pass, every mask, every raw component? Before rendering, ask yourself, what am I actually going to use in post? Keep the important ones. For example, light mix, light selects, Z-depth, masks, AI enhancer, a denoiser in V-Ray, if your workflow needs them. The rule is simple. Render the elements you need, not the element you might possibly use someday. Render elements give you control, but too many of them will create unnecessary overload. Another mistake that can completely destroy your render is working with the wrong scene units. For example, your main scene is modeled in centimeters, but the imported object is in meters, another in inches, and suddenly your scene scale makes no sense. At first, everything may look fine visually, but then the troubles start. Let me show you an example. I'll delete this carpet and change the units to meters, so this will be the case where the scene is in meters, and I will import the carpet that was created in centimeters. First thing, the scale is wrong, so you scale it up to match your scene. And now, look what happens with the displacement. Depending on the scale, it will be invisible, or it will explode. Here, we cannot see anything. The parameters look fine, but it doesn't seem to work. We can see the change when the parameters are higher, but it's very unrealistic. Why? If your material is set to displace by 2 centimeters, but your object or scene scale is wrong, the renderer may interpret that value completely differently. A nice carpet fringe may disappear like in our case. A brick wall can look like mountains. A sofa material can become disaster. Now, with just one object like that, it might not be an issue. But imagine you have dozens of objects like that in your scene. Your RAM fills up, the render crashes or takes hours, and you have no idea why. Wrong units can also make cameras, lighting intensity, depth of field, fog, and scattering much harder to control. So before you start shading and rendering, check your units. Make sure that system and display units make sense, and the imported objects are actually correct real-world size. Another mistake is merging all scenes without cleaning them first. You have an old project, you like one chair, one lamp, maybe one plant setup, so you merge it into your new scene. It feels faster than rebuilding it from scratch, but many times you are not importing just the object. You are also bringing old materials, unused maps, hidden geometry, broken links, old lights, environment settings, render settings, color management, tone mapping, animation tracks, layers, selection sets, modifiers, and sometimes plugins or scripts you don't even need anymore. And suddenly, your new clean scene becomes heavier, slower, and harder to control. The worst part is that this baggage is not always visible. Your viewport may look fine, but the render preparation gets slower, file size bigger, and missing asset warnings appear, and troubleshooting becomes a nightmare. So before merging an old scene, clean it. Delete unused objects, remove hidden geometry, reset materials if needed, check layers, purge unused assets, and merge only what you actually need. So the main lesson is, before you start tweaking the render settings, audit your scene. Check your resolution, check your textures, check your lights, check your scatters, check your high pole objects, check your render elements, check your scene units, check what you merged from old projects. Because most slow renders are not caused by one bad thing, they're caused by a scene. Slowly becomes heavier without you noticing. Modern render engines are already very optimized, but they can magically fix a messy scene. And once your scene is optimized, there is one more limit you need to be honest about: your hardware. If your scatters are clean, the textures are reasonable, the proxies are in place, the displacement is under control and your render is still crawling, your CPU may be the bottleneck. So instead of asking only which render settings should I change, ask 2 more questions. What my computer is calculating that the viewer will never see? And is my workstation powerful enough for the level of work I'm asking from it? These 2 questions will save you hours. See you in the next video. Bye bye!